Hi, everybody. So I wanted to talk about a method of fretting, the glued-on fret method, and also demonstrate the repair of a glued-on fret. So first we'll talk design goals and strategies and techniques, and then we'll get to the repair. 1984, I was working with Larry Fishman informally. We had a friendship that was lived in different states, and it was hard for us to see each other, but we called each other on our landlines, sometimes a couple times a day, and we're in touch on all kinds of things that we were doing, and we were mailing things back and forth to each other, tools and adhesives, materials, food. And during this time, Larry was working on developing a bunch of new products with piezoelectric elements, or piezo ceramic or piezo ceramic. All of those are correct. And he was scheduled for a trip from his home in the Boston area down to my home in mid-state Connecticut. And before he hung up the phone, he said, I've designed a new pickup. I can't wait to show it to you. And I hung up the phone and I thought, well, if Larry's going to design a new pickup, maybe I better design a new guitar. So that was the first fly guitar was born that day, when I just cobbled a bunch of junk together. This is the guitar that I made that day, the day before he came to visit me at my shop, my home and shop at my grandfather's house in Connecticut. And this is, my usual 2x4 material neck, the Douglas fir, and a flats on Douglas fir, just a quickie. And these are cedar sides here. And then you can see there's a bunch of fiberglass and carbon fiber on the back of the neck. And when I had this in a vacuum bag, fortunately it was outside my house, and I hopped on my motorcycle to go to the hardware store. And when I came back, I'd found out that the vacuum pump had destroyed itself and of course quit working. And so I'd lost vacuum, and just when the resin was setting. So it got all bunched up and it was a mess, and which is why there's these crazy green patches here, which were me just scrambling to save the part. After it cured, I just filed off the wrinkles and filled it with auto body filler. That's what this green stuff is. Anyway, then the next day when he came, I had this part, but I didn't have a fingerboard. But what I had done is I'd cooked up a fingerboard. Here it is. This is carbon fiber, and the top face is fiberglass cloth, which you can see the weave is 0-90 degrees. And for frets, I took some of this this K&S brand brass tubing. This is 3/32 of an inch, or 0.93 93 thousandths diameter brass tubing, and I made a fixture on my surface grinder. I ground away half of it and then bent it. And then Larry turned me on to this thermosetting adhesive, this blue stuff here. And so I bent the frets, and we held them on with our fingers and put a soldering gun on there to try and tack the fret down in place. And as you can see, some of them fell off. But honestly, we were getting so badly burned by putting these frets on that we quit after about, we got 12 or 13 frets on, and then we quit. And then it looks like we put it on with hot melt glue. So this was the original fingerboard for this first fly guitar here. And somebody asked me why it's called the fly. And it's interesting to know that all throughout industry, often the playful or silly name of a project carries on and becomes the name of the product if it eventually comes to market, like this one did. And this was a German no pest strip. We had a big roll of this this nice paper. There's aluminum on the back. It was good material to make stuff out of. And while I was in the machine shop in my grandfather's house making something for the guitar, Fishman was in there cutting this out with scissors, and he stuck it on the guitar. So when I came back into the shop, it was there. He had glued on this fly symbol. Anyway, that's that story. So that's the name of the fly. And I always thought of it as fly, as in flight, as in Icarus. Not this bug, but the idea of flying. Anyway, brass is not a good fret wire material, and the fingerboard was kind of a mess. So we ended up making these fingerboards. Here's one from 30 years ago. And this is 10 thousandths or 0.25 millimeters of carbon and 10 thousandths or 0.25 millimeters of fiberglass. Again, with the fiberglass is woven and the fibers are oriented in 0 and 90 degrees fiber orientation. You can see you can crack it. You can crack it especially in this direction because the carbon fibers are all in the 0 direction. Where you want carbon fibers is in the load path, that is. So in other words, carbon fibers going this way aren't so helpful to the structure of the guitar. And then something that we got for free, so to speak, was because we laminated an unbalanced layup. In other words, there was cross-grain fibers in the fiberglass cloth and no cross-grain fibers on this side. Again, half carbon, half glass. When we took it out of the press, it automatically sprung into a curved shape like this. And so it was already wanting to curve in the correct direction for guitar fingerboards. Then we contracted with a wire company to make these beautiful frets. And these frets were rolled in a continuous process. And the frets are 304 stainless, which is a very tough and hard stainless steel wire. And just to say that the alloy in this fret wire makes other stainless steel fret wires seem like silly putty in terms of hardness, because the 304 stainless wire we had rolled into this shape. So this is a half round shape. And in fact, you can think of this as a cotter pin, this wire. So this is the same shape as a cotter pin. If you know what that is, the two of them together would make a circle, and so be used to make cotter pins. And in fact, after this first try with the half of a brass tube, I called a cotter pin company in Rhode Island, and the nice man sent me 50 feet of what turned out to be fret wire that I used for the first couple of years there. We specified it. First, I had one groove, and then I specified two grooves, and the two grooves fulfilled two purposes. One was it helped to hold adhesive, and also was a nice place to put your applicator tip while you were dispensing adhesive. In other words, let me just remove one of these. When you were squirting adhesive on here, you had a place to put the applicator tip so that when you squeeze the adhesive out of the hypodermic tube, it would land right down in the middle of the fret, which was helpful. Now, the other thing that these two grooves do is useful in repair, and we'll get to that when we work on this guitar, which has an errant fret. So what they do is they leave two piles of glue here and here that go all the way across the fretboard and are perfect for realigning the fret in exactly the right place where you'd like to glue it back. Let me tell you a little bit more about this fret wire thing. So first of all, we searched and searched for an adhesive that was going to be appropriate for gluing stainless steel wire to composite material. Now, the challenge is that the stainless steel wire has, a significant thermal coefficient. In other words, it changes size in response to changes in temperature. Whereas this high temperature epoxy resin, fiberglass, and carbon fiber structure that is the fingerboard has near zero thermal coefficient. It doesn't care what temperature it is, it just holds still. I mean, I don't want to make too much of it because it's not huge movement. On the other hand, if you used a really hard adhesive, that would probably be a bad decision because you wouldn't have any elasticity to help hold the fret in place if things moved around a little bit. We needed an adhesive that had a little bit of elasticity, not too much, and also could be cleaned off. So, I mean, it's easy to find a nice epoxy to glue the frets on, but how the heck do you glue on all these frets and then clear off the adhesive that's necessarily going to be smeared all over the place while you're trying to glue them on? So we couldn't figure out a way to do that. And so we ended up using an acrylic adhesive, and those of you who remember rear view mirrors in your car that were attached to a little glob of metal glued right onto the glass, they don't do this anymore, but when we were young, they did. And that acrylic adhesive was used for that job. The kind that we used was a medical adhesive made by the Dymax company, and it was called Multicure because you could cure it with heat, about 125C or 250F roughly, or you could cure it with ultraviolet light, like they did when they put that little block of steel on the inside of a car windshield. The sunlight would hit the adhesive and it would kick the adhesive coming through the glass. And then the third way of doing it was with a chemical activator. So another group of chemicals that would initiate the polymerization of this acrylic adhesive and create a good bond. So obviously we used the activator method because it wasn't okay to get this material too hot. The temperature that this acrylic adhesive cured at was too hot for this material to tolerate. And then also we couldn't, obviously you can't get light in because everything's opaque. So we used an accelerator to cure the glue. So the accelerator would go on the fingerboard, the glue would go on the fret, and there was a crazy fixture that made sure everything was in the right place and all the frets were straight and correctly spaced and clamped down with quite a lot of force. Now, you can see on this fingerboard that where the fret is going to glue is cleaned off. The adhesive in the fiberglass cloth is cleaned off. And first we did it with sandblasting, and that was kind of a mess and difficult. And then we finally ended up doing it with a laser, which was, pretty fancy 30 years ago. But anyway, that's how we did it. So the laser would go in there at low power and blow away the hardened adhesive and expose the glass fibers. And then we could get a good bond to the glass fibers and not play around with trying to bond to the resin surface. Okay, so I think I've told you. Oh, well, obviously I just tore a fret off without saying anything about it. And, adhesion is an interesting thing. I mean, you can push pretty hard on this and nothing happens. And actually the service of these frets turned out to be really good. And of course, there's always a failure or two here or there. And, people make a lot of it, but actually in terms of the percentage, it was very few. And there was always a reason for it. Although, if you're not sick of the minutiae about this, I will tell you that when we first evaluated the methacrylate adhesive for this job, before we started shipping guitars, and I was trying to figure out, is this adhesive strong enough? And we were doing torture tests and trying to figure out how cold and how hot you could get it and still have the bond hang in there. This was developed for the medical industry, I believe, and it was an expensive adhesive, And you couldn't just buy a tube of it. You had to buy a little box of it. It costs a fortune. So we buy our little box. We perform the tests. Everything's cool. We put everything together. We used a saw to cut the frets and the fretboard off. And you can see on this part, the saw has been used on one side, and it does a nice 22-degree bevel on the fret ends. Everything came out great. And the saw was a 2-inch diameter solid carbide saw, about 0.5 millimeter, 25 thousandths thick, with a lot of teeth on it. We fed the part very slowly with a hydraulic cylinder, a lot of control, very heavy, clamping. And it worked great unless the bond was weak, in which case the fret would pop off. So our production method was also a quality assurance method. In other words, if the frets were able to stay on through the sawing operation, we knew they would stay on the guitar. When we reordered adhesive after we'd finished the first batch, we started having adhesion issues. And I called up the company and I said, any chance that the batch of adhesive that we just got is out of spec? And they said, well, send us some. So we sent it back. They tested it and they said, no, it meets our specification. So it turned out that the first batch of adhesive that we got to test and to make the first bunch of guitars far exceeded their specification. And I don't know what little parts of their process formulating this adhesive changed the strength of the adhesive. And in this case, we would be interested in what we're calling shear strength to hold the fret on. But it definitely came in different strengths. And so we had to wait a while and then reorder adhesive coming from the next batch. And we ended up actually stocking a lot of adhesive that we would test and make sure that we were using. Boy, it was a real pain in the neck. Anyhow, thank you for bearing with me, but wow, what a thing that was. Okay, so now we have frets glued on. And somebody just wrote me the other day and said that he was trying to glue frets onto a wooden fingerboard with epoxy, and he was having a lot of trouble. And I guess I wouldn't think that that's a good idea, because the wood, apart from the thermal concerns that I was talking about a little while ago, between the thermal coefficient of the stainless steel, which is not zero, and the thermal coefficient of the cured composite, which is near zero, that pales in comparison with how much a piece of wood can move in response to big changes in humidity. So I don't think bonding frets to a piece of wood is an okay idea. I mean, I guess in a perfect world, if you could control humidity within a couple of percent, maybe you could get it to work, but I wouldn't bet anything on it, and I think it's probably not a good idea. Having said that, I think gluing frets on is a good idea. And one of the reasons that it's a good idea, I just kind of blew over this a minute ago, but so as I was saying, our fret wire was kind of a simple shape like that. So when the wire manufacturing company gets a piece of wire, it's always a round thing. And so to go from here to here is one thing. To go from here to here is quite another thing. In other words, this is hard enough, but to go from here to here, this 304 stainless material, there was just no way that this shape wire was ever going to become this shape wire. It's just not possible. My wonderful vendor at the wire company told me that they could barely get this to happen. And when I asked him if this could happen, he just laughed at me and said, Ken, we can barely do this. By definition, any stainless that is supplied in this condition with a tang and beads is way, way softer than this rolled hard 304. And in fact, I asked them to make it as hard as they possibly could, which they did. So this wire was really hard and springy. In terms of a failure, usually we found that a failure was due either to, as I just mentioned, adhesive that was too weak. There was a batch that was too weak to be depended on. Or sometimes it could be a little bit of an impurity or some kind of problem. So in practice, what we wanted to have, what the adhesive company specified, was a bond line. They wanted to have a bond line here of 2 to 5 thou. So that's 2 thou, and 5 thou is about 0.025 millimeters. That's not much. What we ended up doing was we used some glass beads that were 0.002 in diameter, and we put them on the fretboard. So those 0.002 beads ended up being spacers to ensure that when we clamped things together, that we didn't squeeze all the adhesive out, and we had the correct amount of adhesive in between the two structures, right, the fretboard and the fret, in order to create the strongest bond line that we could get, which we needed. I don't know, I think that's about all I can tell you about these glued-on frets, except that, you know, of course, any fallen off fret is a horror story, but they really were quite rare. And on this guitar, which was made after the company was sold, so I don't really know anything about this guitar, but this guitar has fret 4 is coming off on one side. It seems to be pretty well glued on the other side. I don't really understand why. The only thing that I can guess is that maybe there was some kind of contaminant, so that there was, I don't know. It's hard to tell why. And it seems like if it had been correct, that they wouldn't have shipped it. But again, this is after the company was sold to somebody else, so I have no idea what their quality standards were. And I don't know. I mean, we wouldn't have shipped a guitar that had a buzzy fret. We were very proud of this system. This is something that I worked on really hard for a long time to figure out how to do this. It was a pretty tricky system that depended on an awful lot of things going perfectly well. But we got control over that. We did a really good job. And we were able to create a fretted guitar that didn't need any fretwork. And we were really proud of that. And we think that there really isn't anything to equal the fret job that came on these guitars. And until somebody does something almost exactly like this, there won't be. All right, I think that's all I can think of about glued-on frets. We'll take a break and come back and remove this fret and then reshape it and glue it back on this guitar in the right place. Thanks.